We will now take a look at another firepower threat defense engine. This time it is going to be URL filtering. The purpose of the URL filtering engine is going to be to provide you a flexible mechanism that you can use to enforce your HTTP, HTTPS traffic control. If you think about the legacy firewalls, legacy security appliances that didn't support application level filtering, the only way to control access to individual websites was to build your policies based on IP addresses, of course including the port information in an access list entry. But this is not a scalable solution and it's not really granular. We know that a single device, a single IP address can host multiple websites that could be potentially managed by different organizations that might belong to different domains. So this solution is no longer valid. With URL filtering, what we will do instead is that we will control access based on individual URLs or maybe groups of URLs, which is what you can do with manual filtering. A good thing about this method is that there is no special license needed to use it. Just go ahead, build your URL objects and add them to the policy. But on the negative side, the issue is that there are multiple websites, millions of websites to be accurate, hosted, available in the internet. So even that this method is the most granular option, it's not actually scalable. But what you could potentially use instead is going to be to perform filtering based on groups of URLs, known as categories, where a category is just a set of websites that share some common characteristics. Like for example, CNN.com and BBC.com, those websites will be classified as part of the news category. So with this option, we can choose a category in the policy and then tell FTD whether we want to allow or drop packets and send to this group. Okay, FTD actually offers one additional option, which is known as reputation-based filtering, where a reputation can be thought of as a risk level associated with a website. So Cisco internally classifies websites to build those different categories, and it also assigns a reputation. And this reputation score is derived based on many different factors, like the age of the website, like the content that it serves, and many other inputs. So this is just another thing that you can use in the policy. For example, if you don't plan to use categories, you want to build a pretty short policy that is going to cut down on those malicious sites. Instead of defining categories one by one, you can simply build a rule that is going to trigger based on the reputation. Okay, this solution, category and reputation-based filtering, which is collectively known as category-based filtering, requires a special license, and specifically it is going to be the URL filtering license, what you'll have to install on the system to use it. Okay, going back to manual filtering for a couple seconds. This option, as I said, is not really scalable, and it's not actually its purpose to use it as the main filtering tool for URLs. What this method is used instead is to make exceptions to your broader rules built based on reputation or based on categories. As we will see in just a moment, the way that we will implement manual filtering is going to be by specifying those URLs inside of objects. We can build objects for individual URLs. We can build objects that will contain multiple URLs. This is known as object group type of URL. But in any case, you will have to think about what type of website is it going to be. Is this going to be an encrypted website, or is the communication is going to go in clear? Because there is going to be a difference between how those objects will be processed for HTTP versus HTTPS. So if you plan to build an object that is to catch communication to a clear text website, you will have to remember that this object is going to be treated as a substring or just as a subdomain when it is compared to the URL in the HTTP request generated by the client. Okay, so what it means is that only part of the URL in the request must match the object. So we have a match for the role that uses this object. And just to give you an example, like when you build an object that includes this value, trainings.com. So this is just the one first level domain. This is going to match obviously the request sent to the domain itself. But in addition, it is also going to match requests sent to any subdomain or individual hosts that are a part of this domain, like a web server, or maybe it is also going to catch anything that's before the domain name, like ndtrainings.com, but not something that doesn't contain the actual string that we have defined in the object. So training something.com is not going to work. And a similar example, this time we assume that we use streaming ndtrainings.com. This is going to be our object. So in this case, we will of course match something more than streaming.ndtrainings.com, but not something less, like this value. So just remember, it's all about substring/subdomain matching when those objects are to be evaluated against HTTP requests. Now, when the request is going to be for encrypted web, this time the device is going to be looking at the certificate common name. So this is going to be the server certificate common name, what it will compare to the content of our object. And the difference is that this time it is only going to be looking at the first level domain and not the entire string defined in the object. So if you plan to, let's say, catch a communication, encrypted communication to something ndtrainings.com, you'll have to build your object using the first level domain instead of specifying something more second, third level domains or individual hosts. Of course, because of that, we have less control in terms of what communication we will be able to match with an object. Now, since in both cases we don't actually specify the protocol, we just specify a domain or entire FQDN without HTTP or HTTPS. The way that you will distinguish between HTTP and HTTPS communication in the policy is going to be by including the protocol as your condition. So for instance, if you wanted to build a policy that will affect communication to abc.com, you would build an object, let's say call it O1, and then if the policy is to, let's say, permit traffic to abc.com encrypted communication, but block clear text, we would have to not only refer to the object itself, we would build two rules, both using object as a condition, but you would have to add another condition. So HTTP for rule number 1, for example, and HTTPS for the second rule. And this is what I would say I want to allow. This is what I want to block. With category-based URL filtering, what is going to change is that the information about URLs and their category/reputation is not going to be statically defined by the administrator. It is going to be downloaded from Cisco. It's going to be specifically one of the Cisco's collective security intelligence clouds. Our FMC will have to connect to this cloud and download this information. Okay, the downloaded categories and reputation data is going to be generally cached on both units, on the FTD and FMC. So at a very high level, we can say that the process is going to look like that. We will have local cache on the FTD unit. We will have a local cache on the FMC. And there is going to be that Cisco Collective Security Intelligence Cloud that FMC is going to be using to query for a URL that is not already in the cache. So initially, FMC is going to download the whole database. And then when our FTD gets a packet destined to, let's say, abc.com from the previous example, assuming that this information is not in the local cache, it is going to query the FMC. FMC is going to take a look at its own local cache. If we don't have an entry for abc.com, we will ask the Collective Security Intelligence Cloud, and hopefully the cloud is going to reply with a category, like let's say in this case it's going to be news, just an example. So this way our sensor is going to eventually know that abc.com belongs to news. Now there are going to be two settings that control or just are kind of like related to this communication. One of them is going to be the integration with the CSI cloud. So this is needed if you plan to ask the cloud to obtain a category of a URL that you don't already have in the cache, and this way you don't know what the category of the URL is. So this must be enabled if you want to ask Cisco about this information. We can go to System and then Integration. It's gonna be this option here. So this should be enabled if you want to send the queries to the CSI cloud, versus this is how you enable the feature, enable category-based filtering, and also how you control automatic updates. So this way I'm gonna download the information from the cloud, and this is what I will use to keep it up to date. Okay, now if you disable the query Cisco CSI for unknown URL option and FTD asks FMC for a URL it doesn't know, FMC is gonna immediately reply back to the FTD with the uncategorized group for the URL. So Cisco is making their best efforts to classify every single web page that's on the internet, but it's actually not possible to provide updates about every single website in real time, because websites change, their reputation changes, sometimes the content is different, domains are being sold, and so on and so forth. So in reality, there is always going to be a group of URLs that Cisco will not know how to classify them, or just the classification is not in place at the given moment, I should say. And those URLs will be put into this special uncategorized group. So once again, if the cloud lookup is disabled, we're going to reply back with this uncategorized group to the FTD for a given URL. Now, assuming that the cloud lookup option was enabled, the default behavior of the FTD is going to be to cache or just buffer traffic destined to a URL in question. So this is like when we wait for a reply from FMC, and FMC is waiting for the reply from our CSI cloud. You're not going to allow the traffic to pass through the FTD until we get the reply back or the process times out. This, of course, adds some security to the deployment, but the problem here is that if you have a lot of communication, a lot of packets sent to unknown URLs, it could severely degrade performance of the FTD unit, since all this stuff is going to be holding the memory, a buffer. And because of that, we might want to disable this option, retry URL cache miss lookup. This is something that is configured in the access control policy. Let's take a look at that as well. Okay, so I'm going to edit the policy. And then we will go under the Advanced tab and General Settings. It's going to be this option here. When I say that I want to edit this, and you will hit on the question mark here, it should move us to the local documentation, to the online help system, and it's somewhere here. It should explain what this option does. It's over here. It says disable this option to allow the system to immediately pass traffic without a cloud lookup when the category is not cached. So what it means is that the firepower unit is gonna allow the packets through, and only when it gets the reply back from the cloud, it will recategorize the website or just assign it to a category and then possibly reinforce the policy. But initial communication until we get a reply back from the cloud is going to be allowed. There are going to be two prerequisites to URL filtering. One is going to be to install or disactivate the URL filtering license, and the other one is going to be to enable the integration with the CSI Cloud. We saw that URL filtering option, so this must be turned on so that the feature is active. Now, the way that we will use this feature, this engine, is that we will have to build our roles in the access control policy. It is going to be this additional tab, URLs tab, where we will select the URL conditions. If you plan to use manual filtering, you will have to define those URLs inside of objects type of URLs, or as we will see, it is also possible to do it directly from the policy. Okay, so just to show you this in action, what I'm gonna do here in our network, we'll go back to the policy. We have two roles in the policy right now. One to allow ICMP communication in any direction, and one to allow telnet communication from the inside to the outside, plus we log communication that is blocked. Okay, I'm gonna say that we will want to allow communication. This is gonna be the goal of our new policy. I wanna allow communication to social media websites. And the way that we will do this is gonna be with category-based filtering. Plus, we will want to block communication to a custom URL. And the custom URL specifically, it's gonna be, let's say, hex.com. And it's gonna be a website. And this is what I wanna block. Now, router 4 is going to act as our web server, and router 2 is going to be configured with local DNS information. I'm going to add an entry for Facebook. This is going to be our first entry, and then the second entry we're going to add for hex.com. And both of these URLs will point to our web server. So this communication is going to be flowing through the FTD. We are on the inside here. This is going to be outside. We will test this from router 2. Okay, so maybe first let's configure our routers. I'm going to go to 4 and enable web server. And then on router 2, I'm going to say that I want to perform name resolution. And you will add 2 entries. Facebook. It's going to be 4 loopback. And then hex, also a server. The same IP address. The ICMP is allowed across FTD, so we should be able to get to those websites over IP. We have connectivity to Facebook, and we have connectivity to the second website. So all is good here in the data plane. We can now change our policy. I'm gonna add a role for social media first. So we will call it social-media-ACP. Okay, the role is going to be enabled, and the URL step is exactly where you enable the feature, where you specify how the engine is supposed to do the inspection. So we have 2 tabs here, categories, including the reputations here, and we can also choose URLs. Okay, so in this case, I'm looking for social media. So I will filter for this output, social network. I choose the category itself, and now I can also couple it with a reputation. Like instead of, let's say, allowing communication or blocking communication to all social network sites, I want to allow or block packets to social network sites with this reputation from 2 to 5. Okay, now in our case, I'm gonna say that the reputation doesn't really matter. So I'm gonna choose any over here, and we will click on social network again and add the rule. So now it says it's for any reputation. We want to allow, let's say, from the inside to the outside in this direction. So the clients are going to be located on the inside. Let's just add this rule. And let me also enable logging here. I'm going to log at the beginning of the session. Okay, and one more rule is going to be to block www.hex.com. And something like this I'm going to do for a custom URL. So this is going to be an example of manual URL filtering. Bad website ACP. This is going to be the name of the rule. I'm going to block. And I will add this URL from here. This is place number 1 where I can do this. The other one is going to be to add those URLs here, make an object, maybe a list, specify this information from here, or you could also go to the objects. Let me just save the policy. And let's also enable logging so we can see this in action. Okay, enable logging, save. And the other place will be to go to objects and object management. There is a special type of an object which is called URL. So we could add a single URL or maybe a group of URLs. Okay, let's push this change. And let's go back to the policy for a second. And now the way that I'm going to test this is that we will go to router 2, which is going to act as our web client. I'm going to use the copy command with HTTP argument. So this is how I am emulating real web client application, like a browser. If I were to use Telnet, it wouldn't be a real test because Telnet does not allow you to fully emulate all browser, just web client settings. Okay, we will now specify the URL we want to access. It's going to be Facebook. And let's say that we are looking for chat. And I want to send the output to null 0. I want to black hole this communication. Okay, we see the result is that it says no such file or directory. So this is a response, assuming that the policy is in place. This must be a response from our server. When we now go to bad website, and let's say that we want to download this file, mw.exe. We see that now result is different. It says accessing, which means that something is blocking the communication. We know that we can get to hex.com. We have IP reachability. So it must be FTD what is blocking this session. And let's take a look at this here in the analysis connection event viewer. We should see 2 log entries. Okay, we see it says I'm blocking communication to 444 from router 2 from a web application, from a browser. This is HTTP, clear text HTTP communication to this URL. It says category is uncategorized. Versus I'm allowing communication to Facebook, it's social network. If we take a look at the details of this first entry here, it should point us to the right rule. Actually, for both of these, it is going to point us to the right rule in the access control policy. We see that we had a match with bad www ACP rule, which is where I configured our URL for hacks.com. So it doesn't actually tell you exactly what was the object that you used to build a rule, but at least it shows you the actual rule. In our case, it's rule number 4.